So in this video, I'm going to show you how to solve the instant insanity puzzle, which is also known as the 4 cubes puzzle sometimes. And the solution is going to use some graph theory. And so if you just recall how the puzzle goes, there's 4 cubes, and each face of each cube is colored one of 4 colors: green, or red, or yellow, or blue, which I've labeled B, G, R, Y. And the goal is to put the 4 cubes in a line so that in every direction, each color appears exactly once. And so if you look at the front of this arrangement, that is what we're looking for. I have each color once. But if we look at the top of the arrangement, we see that this is not the solution because yellow is appearing multiple times. So that's no good. And so there's tens of thousands of different possibilities of ways to arrange the cubes, but up to symmetry, only one of them is the solution. And so if you just randomly guess the solution, it would take you a long time. And you need some kind of systematic way to search through the solutions. And we're going to use graph theory to help us do that. So this puzzle, solving these puzzles is a lot like doing Sudoku or something, as we'll see. And so what I've written on the board so far is just a representation of what's on the cube. So these pictures are just folding out the cube. So if I unfolded the cube, you would see I'd have 3 red in a row and then green. So 1, 2, 3 red in a row and then green. And then, oh, I've got it. Let's go this way. 3 reds in a row and then green, 1 blue on that side, and yellow on that side. And these are, I've done the other 3 cubes just to save time. And then the graph next to it, that's where the graph theory enters. And what we've done there is we've put an edge between the 2 colors if the 2 colors appear on opposite sides. So we see that there's 2 reds on opposite sides, and so one edge is a loop on R, and blue and yellow on opposite sides, so there's an edge between those, and red and green are on opposite sides, so there's an edge between those. And one reason that's a good thing to do is because no matter how you rotate the cube, you're not changing which colors are on opposite sides. And so this is somehow capturing what you can't change. You can kind of change everything else, but you can't change which colors are on opposite sides. And so it's going to make our lives a little bit easier to just make a master graph that has all of these edges on the same graph and just labeled. So between blue and yellow, there's 3 edges total, and I'll write which cubes they appear on cubes 1, 2, and 3. Between yellow and red, there's just 1 edge on cube 4. Between green and red, there's 2 edges on cubes 1 and 3. There's a loop on green, that's cube 2, and a loop on red, that's cube 1. And then there's 2 diagonal edges this way on 2 and 4. And there's 2 diagonal edges this way on 3 and 4. And just to make sure I got them all, there should be, so there's 4 cubes and 3 edges from each cube, so there should be 12 edges. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got them all. And so how am I going to go from this graph to the solution is if I had the solution, then if I looked at the pairs that were on the front and the back, that would give me a subgraph. So I'm going to have 2 subgraphs, one coming from the front and the back edges. Let's space these out a little bit. Blue, green, red, yellow, and one coming from the top and the bottom. Blue, green, red, and yellow. And so what is going to be, and these subgraphs are just going to show, right, since I have, from cube 1, I have one of the edges chosen. And from cube 2, I have a different edge chosen to be on the front and the back. And for each cube, I have a different edge chosen to be on the front and the back. So what they're going to satisfy is that they're going to have one edge from each cube. And then the other thing it's going to satisfy is every vertex is going to have degree 2. So what does the second thing say? Right? Every vertex has degree 2. So what does that mean? That just means that, right, how many times is red going to appear? It's going to appear once on the front and once on the back if it were as a solution, right? Here it's not a solution, it's twice on the back. But that means, right, every time I have an edge coming out of blue on the subgraph, that's a face that's colored blue. And so between the front and the back, there should be exactly 2 boxes of every color. So it's going to turn out that if you have a pair of subgraphs that satisfy these properties and don't use the same edge, then you can backtrack from that to get a solution. That's not necessarily clear. That's a good exercise to try to figure out how that would go. But so this is what we're looking for. We're looking for a pair of subgraphs that satisfy these things. And so, right, and so each cube has 3 edges, so that means of these 3 edges I have to choose one to forget. That's the edge that's going to be going along the cube like this, and one edge to be on the top and the bottom, and one edge to be on the back and the front. And so there's no magic way to find these. You have to kind of do a guess and check, like Sudoku, using kind of basic logic. And a good place to start is guessing that the loops happen. And why is it interesting to do the loop? So let's assume we had the loop on red on the top and the bottom. And why that's a good place to start is if we have a loop, it's already given that vertex degree 2, right? And so that means that I can't have any more edges going to that vertex, and I need a degree 2 graph just on the remaining vertices. So one possibility, so if I use that edge there, one possibility to get a degree 2 graph on the rest would be to have a triangle, but we kind of look over on the master graph and there's no edge on the top. And so the triangle isn't an option. And if it's not a triangle, then one of the vertices has to have a loop. You can convince yourself of that because there's only 4. And the only other loop is the loop at green, which is on cube 2. And then to get a good degree 2 graph here, I'd have to have this, and they would have to be labeled 3 and 4. But we go look on the master graph, and the only edge is between blue and yellow, so 3 is an edge, but 4 isn't. And so this is not a possibility, and so that means that the loop on green isn't a possibility, and so that means the loop on red isn't a possibility. Right, and I mean, you could ask, well, couldn't the loop on red go over there? But you can always interchange the front and the back and the top and the bottom just by rotating your stack of cubes a little bit. And so I'm not using the loop on red, and so that means one of these graphs, and I might as well choose it to be this one, has to use the edge between blue and yellow, and one of them, I might as well use this one, has to use the edge between green and red. Right, and I could have chosen to write them on the opposite sides, but it doesn't matter. So I've figured out cube 1, and now let's go on to cube 2. And using that loop seemed useful the first time around, so let's look at the loop that's on cube 2, the loop at green. And I've broken the symmetry by choosing to put an edge between blue and yellow there. So I'd have to consider putting the loop on both graphs. But we kind of see right away, if I put the loop on green on this graph, I'd have degree 3 right there. So that's already not an option, and if I use the loop, it would have to go there. And now I need to fill the rest of this graph out to have degree 2 everywhere. And I've already seen I can't use the loop on red. We already ruled that out. And so the only other possibility would be a triangle, and these would have to be labeled 3 and 4. And so I go look on my master graph, and the bottom edge could only be a 4, but this diagonal edge is 2 or 4. It couldn't be 3. And so that means the triangle isn't a possibility, and so that means the loop on green isn't a possibility either. And so the 2 edges that are going to get used from cube 2 are the blue-yellow edge and the blue-red edge. All right? But I need to figure out which one goes where. They could have switched around like this. And maybe the obvious thing to try to rule out would be to put the blue-yellow edge on the front and the back, because I already have a blue-yellow edge there. Right? And I would have to have a subgraph of degree 2 on the green and red edges. That's regular of degree 2 over here. I've already seen I can't use either of the loops, and so the only possibility would be to be doubled up like 3, 4, but we see that 4 isn't an edge between those. And so that's not a possibility, and so that means the edge on 2 between blue and yellow can't go over here. It had to go over here, which means the other edge I have to use from cube 2 is between blue and red, so that's going to be here. 2. Right? And so now we just kind of keep going. We've got kind of half of this graph worked out. Let's figure out what the rest of the graph could possibly be. So green doesn't have any edges yet. I've seen I can't use the loop on green. And so the only other way to possibly fill this out to have it be degree 2 everywhere is to do that. And these have to be labeled 3 and 4. And this one could be either one, but this one could only be 3, we see. So that's got to be 3, and this has to be 4. And so I found one of my 2 subgraphs from there. And now I have to look over here and finish the other subgraph. So what is going on there? So I have to use 3 and 4, and you'll notice that there's no edge on the top, and 4 doesn't have any edges on the top and the bottom. So the only possibility is to go like that. You can convince yourself. And this 3 only has the one going that way. So this one has to be 3, and this one has to be 4. And you'll notice, yeah, I didn't use the same edge twice between the 2 of them. Every edge got used exactly once. Those are the only choices. So we found the 2 subgraphs. That's the graph theory part of the problem done. And now let's just see, how do we go backwards from the graph theory, from these 2 graphs, to an actual solution to the 2 cubes problem. And so if we look at the first cube, we need blue and yellow on the front and back. So here's the blue and yellow. I'll just choose to put blue in the front. And for the top and the bottom, we need green and red. I'll choose to put red on top. So I've got red on top and green on bottom, blue in front, and yellow on back. Okay? Now we go to cube 2. And for the front and back, I need blue and red. So here's red opposite blue, and I already have a blue in the front on the first cube. And so that means the red is going to have to go in the front, and the blue is going to have to go in the back. And then for the top and the bottom, it's got to be blue and yellow. And I haven't used blue and yellow on the top and the bottom yet. So I don't know yet from cube 1 which is going to go where in cube 2. I don't know if blue is going to be on the top or blue is going to be on the bottom. And so to figure that out, it's maybe worthwhile going to cube 3. And what's happening on the top and bottom on cube 3 is yellow and green. Okay, so I either had to have, I've got green on the bottom already on cube 1, and on cube 2, for the bottom, my choice was either blue or yellow. So if I put yellow on the bottom for cube 2, I've already got green and yellow on the bottom. And then when I go to cube 3, which is supposed to be either green or yellow, there's no options. Right? And so that means that the yellow, looking ahead a little bit, I see that the yellow can't go on the bottom. The yellow is going to have to go on the top. So let's just double check. I've got cube 2 right. I've got blue and red on the front and back, and yellow and green on the top and bottom. Oh, blue and yellow on the top and bottom. Yep. Okay. So now cube 3, I see that, I've just decided we just thought we were going to have green and yellow on the top and the bottom, and it's got to have green on the top and yellow on the bottom, because I already have a green on the bottom. And then for the front and back of cube 3 is green or red. Here's red and green, and I already have a red on the front, so I have to have green on the front and red on the back. And then finally, cube 4, on the front and the back, I need yellow or green, and here's yellow and green, and I already have a green on the front, so yellow is going to go in the front from cube 4, and for the top and the bottom is going to be blue and red, and I already have a red on the top, so it's got to be blue on the top. So So blue on the top, red on the bottom, yellow on the front, green on the back. And so this should be the solution. Let's just check. So that's, the front's fine. If I rotate it once, it's fine. If I rotate it twice, it's fine. And if I rotate it 3 times, it's fine. So that is the solution to the 4 cubes problem.